Thank you, and good morning. I am a principal engineer, not the principal engineer. Companies all have different naming conventions for how they label their staff. I'm going to talk about 30 years of XR history. So from 1989 to 2019. So I started work at Electric Boat in 1989, which makes me old, right? 30 years of XR, VR and AR actually been around for a long time. But I actually graduated in 79, so I've got another 10 years in there. So if you want to hear about wind tunnel control systems at NASA Langley, or spreading the gospel of Jesus in communist Eastern Europe, or teaching high school, you can come talk to me afterwards about that. But so 30 years, I'll go back to this timeline and kind of place things so you have a context of where things go. So a little bit about Electric Boat. Electric Boat was founded 120 years ago, so now that's old, right? So in 1899 it was this inventor, this crazy Irish immigrant, John Holland. Some financier helped him finish his first modern submarine, the USS Holland, that was bought by the US Navy in 1900. And for 120 years, Electric Boat's been building submarines. So we have one product. These days, we have one customer. It's not a good business model. I wouldn't recommend that. But if you're successful, it actually can work out well. We're part of General Dynamics, so the large defense contractor. Electric Boat was actually the founding member of General Dynamics. Was founded back in the 50s. We're currently building the Virginia-class submarine off there in the top right, and we're starting work on the Columbia-class, a new missile submarine replacement. Okay, so VR, MR, AR, XR, right? Lots of R's, realities. We've been working in these things for a long time. These all go way back. I'm gonna talk about each one of these a little bit, some more than others, and we've been involved in these. There's some non-R issues, computer vision, Wi-Fi, mobile, that all tie into this larger XR framework. So the visualization landscape, right? So in the late 80s, early 90s, visualization was a different animal than it is today. The PC, the Mac, right, so it's mid-80s, so those were around, but there wasn't really much in the way of visualization software per se. OpenGL didn't exist yet. It was IRIX-GL, was dedicated to Silicon Graphics machines. DirectX didn't exist. Windows existed, but not really the Windows that you think of on the Microsoft side until 1995, Windows 95. On the Unix side, X Windows, standard windowing for Unix workstations didn't exist yet. That was Project Athena from MIT in the early 90s. So it was a different world, right? It was everything was hard. Thinking? Okay. So at Electric Boat, we were an Apollo house. So again, history, I don't know how long you've all been around this world, but we used Apollo workstations. Companies come and gone. They were POSIX compliant. They were not Unix per se. It was a rewrite, but essentially a Unix type workstation, distributed network operating system domain. There was no standard for user interface programming, no standard for graphics programming. Everything, the graphics were all specific to the hardware vendor, pretty much. No 3D solid CAD model, so in terms of content. So we actually had some CAD software. We had something called CADS, C-A-D-D-S, by a company called Computer Vision, which has nothing to do with computer vision. It was a CAD company that made CAD software. But our CAD models, it was essentially computer-aided drafting. They were 3D wireframes, but they were one of my first projects on the software side at Electric Boat was a model checker that checked whether the line segments that made up these wireframe models actually touched at the corners. So you got what was essentially a solid model rather than a bunch of disconnected lines, right? So yeah, it's a different world back then. And even things as simple today, you think of Z buffering. Let me go to my next slide. So this is some early visualization work. This is a fire simulation model from WPI. It's my alma mater. This would typically be a printout, a paper printout, bifold, you get a stack of papers an inch thick of run results from the simulation model, numerical simulation of fire spread. And we were able to draw pictures of that. But in the picture, you can't just put, Okay, you can't just put, you can't just throw this all into the Z buffer and let it render to see what's visible from the front, because Z buffers were slow and they took up a lot of memory, and most of our workstations didn't have graphics memory in them per se. And so this actually used a painter algorithm, so you draw the things that are in the back before you draw the things in the front. And there were other competing technologies, BSP trees, binary space partitioning. There were all kinds of things that you could do instead of a Z buffer, which everything was just complicated, right? The other thing to note here is there's, up here you see rotate and reverse. The manipulation of the 3D model was actually not by the mouse, so you'd actually click on the button because it wasn't interactive anyway. So you move, the thing would, you could see it redraw. Draw, move, draw, move, draw. It was, so if you had a mouse, there'd be no way to keep track of the position with a mouse. Didn't work. And then we moved on to this. So this was early on in my career at Electric Boat. We built this 3D submarine. And this is my claim to fame. This is not very impressive right now when you look at it. But back in the day, this got everyone's attention, because no one, here we've been building submarines at this point for 100 years, roughly, 90 years. No one had ever seen a 3D submarine on a computer screen, right? They just, because you didn't see that. All the drawings were on paper, they were flat. We were starting to do some 3D modeling, but the modeling, again, you'd only see one part at a time. You wouldn't see a whole submarine. So this was really a remarkable thing. And it's interesting to note the model, so this looks like a CAD model. It's actually a finite element analysis model that was built from drawings, probably by hand. So someone constructed this 3D model to run FEA analysis on it, finite element analysis. And it was not a CAD model, didn't exist in our CAD system as such. And again, here you see down at the bottom, there's buttons for rotating and manipulating. You can do cutaways, this cutting plane. You could set all that up and then hit the draw button, because this picture would take 20 seconds to draw. So every time you made a change to it and redraw, chugga, 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 you could almost watch the polygons, the triangles come onto the screen. It was pretty amazing. This was run on we had a 590T turbo workstation, 16 megabytes of dedicated graphics memory. It was the top of the line Apollo machine for computer graphics. So again, this is just the background history of landscape at the time. In the bigger picture historically, right, so in the late 80s, early 90s, you have the fall of the Iron Curtain, the end of the Cold War. We were building the Seawolf submarine, a new design, and instead of building 30 submarines, the Navy decided to only build 3, really only 1 at first, so they cut that program. And Electric Boat, which was a big company at the time, we had over 20,000 employees. We went down to under 10,000 in the space of probably less than 5 years. So it was a critical time for the company. Sorry, I get talking too fast when I'm up on stage. So we had a new design that was coming up, and we had to make sure that we would win this new design. So we needed to impress the Navy that we had cool visualization technology so that they would choose us to design the next submarine, so we wouldn't go out of business after 100 years. All right, so we worked on this large-scale VR implementation. Just some slide notes here. So I've got a couple of slides that have references to conferences that deal with the subject matter, SIGGRAPH, Big Computer Graphics Conference. You'll see those throughout the slides, so when you look at the slides later, you'll be able to refer to those. We worked on this large-scale VR implementation. We didn't even call it VR. So again, historical note, the VR had already come and gone, right? So it had already gone through its first hype cycle. VR was a bad thing because it didn't work. And so we just called it visualization. We didn't call it VR. But you can read a little bit about this in Fred Brooks, one of the pillars of computer graphics. We had the opportunity to work with University of North Carolina, Fred Brooks, and Dinesh Minocha in the mid-90s with a DARPA simulation-based design project, but he writes about this as one of his what's real about virtual reality in the late 90s. So we built this thing called EVS, Electronic Visualization System. There was no model visualization software. You couldn't buy something that was a visualization package. They didn't exist, right? So there was no software like that at the time. You couldn't even buy graphics, big graphics computers. I'll talk about that in a minute. You could. They were, you get image generators for flight simulators and things. They were tens of millions of dollars, custom built. A couple of us had worked on some visualization stuff internally in the company, and so we had to decide, were we going to write this ourselves from scratch, or were we going to buy software? Software was, there wasn't really a big choice of software, but we ended up choosing this thing called iGrip from a company called Deneb Robotics. It was an offline robot simulator that happened to run on silicon graphics, so it went fast, and they had an open API and file format for getting data in. So we designed a submarine with a robot simulator. But that was the state of the world back then, and Deneb was bought by Dassault, who makes CATIA. We were designing in CATIA at the time, and Deneb became Delmia, part of the CATIA family. Okay, so this is the system that we built. We built some dedicated rooms. We had big projectors, CRT projectors, so 3 television tubes, a red, green, and blue, in this big box. Took a technician a whole day to calibrate to the screen. It was all complicated and hard back then. It was one of few systems like this in the world at the time. Boeing did similar things with their design on the 777, the digital pre-assembly, but for ours, all the pictures were classified, so if you weren't in the Navy or Congress, you never saw it or heard about it. So we were famous and nobody knew it. We had this data path from CATIA, so we had designers working in CATIA. We had, talk about content creation, we had a couple thousand people working 8 hours a day generating content for us. So we had plenty of content to draw. We built a translator to get the data out of CATIA, polygon format, put it into this iGrip software. We had a translator that ran every night. So there's the whole model is like 1 million parts, tens of thousands of models. We were translating hundreds of models a night, tens of thousands of parts. So it was all the automated system. Okay, and to run that, to draw those pictures, we used this monster thing called an SGI Onyx. At first, we actually started with a Power Series machine. The Onyx hadn't come out yet. SGI, Silicon Graphics, come and gone, right? So if you head up the 101, the freeway, a couple exits are up by Moffett Field. There's a big office complex that used to be SGI's headquarters. It's now owned by some internet search startup, Google, something like that. So these machines, fully configured, they're about $1 million a piece. The base machine was probably $250,000, but when you put, we actually had up to 6 gigabytes of RAM in one of these, which at the time, my first PC that I bought had a 2 gig hard drive, right? So you put that in perspective. If you bought a PC today that had 2 terabytes of RAM, right? That's what we're looking at here. So big monster machine. We actually got to do, I did testing on SGI chassis number 2 for some of our early work to make sure the software ran. Okay, so the reason that we did that was to replace a wooden mock-up. So historically, for submarine design, they would build a wooden mock-up for each new submarine class. The one on the left is from Electric Boat. The one on the right is actually from Mare Island, Vallejo on the east side of the bay, a little further north from here. But because the first submarine that you build actually goes to sea for 40 years, you don't want to make any mistakes. You got to make sure everything fits, and you're cramming a lot of equipment into this little space. So we'd build a full-scale plywood submarine, and we replaced that with this electronic mock-up where you could draw the whole design. You'd have nightly updates, so the next day you could get the entire engineering staff, design staff in to look at the model as it exists today, which had never been done before. It's a big cultural shift in design. Historically, you had these siloed discipline designs on paper, and things took a long time, and it was very complicated. Okay, so that one took about 10 years to do. We also had some immersive visualization, right? So this is something called the Boom from a company called Fake Space of Mark Bolus, and Ian McDowell. So you think VR is cool and new, and that Lucky Palmer invented VR, but really the Oculus is kind of the great-grandchild of this device, which was invented by Mark Bolas, who taught a course at USC that the Oculus guys got involved in. So anyway, immersive visualization was tied to one of these big machines, but it was a $150,000, $200,000 display tied to a $1 million computer that only one person could use. It didn't get a lot of use, so it was unfortunately. All right, so some other things. So we've got supporting stuff. Mobile computing. We did some work with mobile computing early on. You may recognize these, you may not, right? So I actually had a Palm Pilot that I used for a long time for taking notes. iPac, coolest little device ever, right? So you could see the world at 320 by 240, right? It was great. Color screen. And then some CMU, Carnegie Mellon. We worked with Asim Smailagic from Carnegie Mellon on a project a little bit. I actually wanted to get a picture of some GD wearables. We had a GD division that built things that were like a diving belt with a CPU module on the battery and a tethered screen and a headset. And I couldn't find any of my old photos. I had one of the units at home. I threw it out. So we did some wireless networking stuff. So our wireless stuff goes back. There were these things, WaveLAN cards, PCMCIA cards, come and gone, right? So you may not even recognize what these are. We were doing wireless before it was even called Wi-Fi. Right? So wired fidelity was a term that came later on. Bandwidth, originally in the hundreds of kilobytes, and megabits per second to 11 megabits per second was the sort of the high end of these, which gave you about 1 megabyte per second, which was enough to stream video. Not HD video, because HD didn't exist yet at the time. And on the bottom picture, that's an access point. You'd actually put the cards into this electronic device. The cards had the little radio in them. We did some early remote expert work. So this is out at the Bangor facility in Washington. So we were on board. I couldn't show you my submarine pictures. These are public pictures. But we had somebody on board with a mobile computer, tablet, wireless, and then an access point up to a wire to an antenna, over to another antenna, back to a WAN, wired WAN, back to electric boat. And then we had somebody at a desk at electric boat. Oh. Oh. There should be a video on that one. Can you click on that? There we go. Cannot play media. Oh. Okay, so what you're not seeing is this net meeting, Microsoft net meeting conversation with somebody walking around live on the submarine, somebody back at a desk in Groton. The date there, 2001, right? So a long time ago. So we did some mixed reality stuff. Mixed reality used to be virtual reality with physical props. So you were mixing realities. Now, all of a sudden, Microsoft wants us to think that mixed reality is virtual reality with tracking. Well, what's that all about? Virtual reality is virtual reality. And don't get me started on holograms, because that's not what you're seeing on that screen. But so we did a little mixed reality thing. We built this virtual welder. So the manufacturing guys saw what we had done with the virtual submarine for design, so they wanted virtual stuff for manufacturing. So we built this weld simulator where VR goggles, you held a physical weld torch and you simulated a weld with software, figuring out how good of a weld. And this actually became a product down here on the right. This is the Lincoln Vertex 360 weld simulator you can buy today. Okay, running out of time, I want to get my AR stuff. So computer vision, we did some computer vision stuff. We built this tool for measuring, these are little test plates that they use from the cutting machines in our steel fabrication area. They'll make sure that the cutting tools are aligned because there's different potential cut steps. And so we built a tool with a digital camera and a video camera to do a depth measurement. So we're using OpenCV. And so all of that leads us to AR. I want to spend a little bit of time talking about our AR implementation that we're working on. We started in 2013, which maybe that's a long time for depending on how long you've been involved in this, but actually it's all relative, right? So AR really goes back to 1992 with the Tom Codell and Dave Mizell. We actually got to work with Dave Mizell a little bit on that same DARPA project in the mid-90s. Coined the term augmented reality in 1992, right? So that goes way back. Steve Feiner, who presented here earlier this week, had mobile AR with a backpack and a laptop and GPS kind of thing outdoors. Magic Book, so you marker-based pop-up pictures on a marker with a camera. Mark Billinghurst, he was here as well yesterday. The Invisible Train, so this was mobile AR. This was ran on these PocketPC devices. Windows was, PocketPC was, it was like Windows CE, I guess. Dieter Schmalstieg, I noticed his name on an AR book in the back there. And then PTAM in 2008, 7, 8, 9 timeframe, you have this group at the University of Oxford who developed a SLAM system that really kind of took over modern AR. So all of modern AR really is based on the SLAM work that was done. George Klein, David Murray, Rob Castle, Andrew Davison. George Klein went to work for Microsoft and developed this AR headset thing you may have heard of, HoloLens, part of the team on that. In 2013, we got a request to work on, to show AR for wire installation. And some people had seen things in the technical popular press that, AR, you could show, stuff under the road, you could show restaurant menus, walking around town, and yeah, you could do that in Hollywood or in a magazine, but not in real life. It was hard. So we played around with this PTAM thing, we did some marker stuff, KinectFusion, Metaio, right, coming on, Real Sense, and then Tango. We started using the Tango. We built, so this one probably won't play either. Can you click on that, see if that one's got a, okay. Well, that's unfortunate. So you're not going to see any of my video. You can come find me later today. I can show you some video. So I presented here a couple years ago on this. We did 3D wire overlay with augmented reality with the Tango. This used a marker to get registration. This was a National Shipbuilding Research Program project. And then we moved on to doing AR for part installation. So inside the submarine, we install a lot of equipment. You have to measure to get things in the right place. Everything has to be done according to a drawing. But measurement's hard because it's round, and you measure to this grid line of reference marks that you can't see. They're off in the outboard somewhere, and they're always behind something, so you can't pull a tape measure to them. It was very complicated. But we developed a system using the Tango where we could register to the local coordinate system and draw geometry. We could extract. We knew we'd been doing this for a long time, so we knew how to get geometry out of our CAD system, PLM, and reformat it to draw on the device. So we made a simple app that ran on these Tango devices. And this is a picture. I only have a couple of public release pictures because it's all classified again, sorry. But this was released. So this is the underside of a deck. This is steel. And we shoot a lot of these threaded studs. It's like a bolt that welds in with threads exposed, and you mount things on it. So here there's what's an electrical hanger. It's a couple pieces of angle iron and a plate with holes in it that fit on 2 of these studs and get bolted on. And some have 2, some have 4. And so with our tablet now, we're able to register to our local coordinate system and walk around, and now these hangers show up in their correct locations, correct orientation, part number, so you know which one goes where. And as quickly as they can go around, they'll mark these with a Sharpie right on the steel and then come back and bolt them on. We can't save time for the bolting on, right? I mean, they bolt them on. It takes a couple minutes to do that, but we could save a significant amount of time finding where they go originally. This is more video that probably won't play. No, here, sorry, back to that. Cannot play media. Oh, okay. That's unfortunate. So this just shows at my office again, because we couldn't release the real video, but the hangers, you've seen AR, right? So you walk around, hangers show up in the right place as you walk around. We've been using this in production now for electrical hanger installation. We have a process improvement engineer working on this, collecting metrics, because everybody likes metrics. So we've saved hundreds of hours, probably probably roughly 1,000 hours of use. Saves about 10 minutes per part that we install, depending on how there's different ways to count how much the time savings is. It's a little complicated because we don't do the exact same thing over and over again. Submarines are built like a year apart, so it's a little hard to compare historical data. But we're using this, doing the same kind of work in 4 different places inside our shipyard. Yeah, so 10 minutes roughly per hangar saved. There's tens of thousands of hangars, so it's a significant amount of money. And the idea is it helps you to find where you go faster. And there's also quality issues, right? So the picture, this is that same picture, picture reuse, because I only have one picture I can show you. But there was this hangar that was installed already when we got there was in the wrong place. It was off by 3 inches, was in the right orientation, but it was off by 3 inches. And we found this in one of our early pilots, and we couldn't believe it. So I went back, I did my registration again, came back, went back, did my registration again, came back, and it was off location. I told the guys there, and they looked it up in the drawing, figured it out, and they moved it. And so that was a big win for us. And again, this probably won't play. Click on the video. Yes, okay, all right, so you're not seeing any video. But so we've got these Tango devices, we've got it in a 3D printed plastic case, and you walk around and hangars show up on top. These hangars are already here, so this would be like an inspection task where they're checking to make sure the label's in the right place. And again, the first time we did it in this application, we found a label that was mislabeled, a hangar was mislabeled. But again, it's a simple app, runs on the device. Everybody uses it. They have phones, so they know exactly how to run things. Only a couple of buttons, really easy. Shows you the part, the location. And it's considered a manufacturing aid. It's not a replacement for the drawing. The drawing is still the official documentation. The Navy wants documentation and sign-offs and all that. But this it saves them time doing their real work. Okay, so we're going to expand into future production work. The Tango, of course, is dead now. So this application actually would run an AR core, but our IT people don't like the Android devices anyway. So we're looking to do something on a Windows tablet because we're deploying Windows tablets in the shipyard for work instructions anyway, mobile work instructions. So we're looking for either a software-only solution, or right now we're using a RealSense camera that's got built-in SLAM, which kind of works, kind of doesn't work. So if you have some cool, general-purpose SLAM software or hardware device, SLAM on a stick, there's a couple of those out in the exhibits there. I would be interested in talking with you. The data process right now is pretty automated, but it's not fully automated, so you can't go in. The idea is you want to have on demand from the tablet, from the shop floor. The guy clicks on his work order, and the data streams to his device and gets that data right then. We don't have that now, but that's what we're looking to do, and expand then into other disciplines. So right now we just do these electrical hangars, but we could do pipe, we could do equipment, we can do inspection. We have a long list of use cases that we're going to pursue. So there you go. So in my mind, I've done 2 significant things in my career of 30 years, which is either terrible or really good, depending on how you look at it. But had a lot of fun along the way, and I guess you call that XR. I don't really know what the whole XR thing is, but just a way to kind of bundle all of these different R things into one big bucket. And again, I can show you some pictures probably later on if you come find me if you really want to see some video. So I think I have 2 minutes 1 minute, no minutes for questions. Sorry.